Interactive containers and shell access. Docker allows direct interaction with running containers. Developers can execute commands inside containers. Shell access helps with troubleshooting and administration. Interactive containers are an essential Docker skill. Why interactive access matters. Developers often need to inspect running applications. Configuration issues may require investigation. Troubleshooting becomes easier with direct access. Interactive sessions provide visibility into containers. Common reasons for accessing containers. Inspect files. Check configurations. Troubleshoot problems. Verify installations. Test commands. What is an interactive container? An interactive container connects to your terminal. Users can type commands directly. Output is displayed immediately. Useful for learning and debugging. Benefits of interactive containers. Real-time interaction. Easier troubleshooting. Better understanding of container environments. Faster issue resolution. Understanding terminal access. Most Docker containers use Linux environments. Linux shells provide command line access. Commands execute inside the container. The host system remains separate. Common Linux shells. Bash, sh, zsh, ash. Bash and sh are the most commonly used in Docker containers. Running an interactive container. Command. Docker run at Ubuntu. Starts an Ubuntu container. Opens an interactive terminal session. Breaking down the command. Docker run. Creates and starts a container. I. Interactive mode. T. Terminal mode. Understanding the I option. Keeps standard input open. Allows keyboard interaction. Enables command entry. Required for interactive sessions. Understanding the T option. Allocates a terminal session. Improves user interaction. Provides a familiar command line experience. Makes output easier to read. Using int together. Docker run at Ubuntu. Interactive session starts immediately. Users gain shell access. Commands execute inside the container. Recognizing the container prompt. Example. Root at A1B2C3D4 /#. Indicates you are inside the container. Commands affect the container environment. Host system remains unchanged. Running commands inside containers. Examples. pwd. ls. whoami. Hostname. These commands execute inside the container. Exploring the file system. ls. lslaw. cd. Containers have their own isolated file systems. Viewing system information. Useful commands. Hostname. uname. cat/etc/os release. These commands reveal system details. Understanding container isolation. Containers have separate file systems. Processes run independently. Applications remain isolated. Host operating system is protected. Exiting a container. Command. Exit. Ends the shell session. Container behavior depends on how it was started. Running containers in background mode. Many applications run continuously. Background mode keeps services running. Terminal remains available. Common for servers and databases. Detached mode example. Docker run dean jinx. Container runs in the background. Docker returns a container ID. Service remains active. Introducing Docker exec. Docker exec runs commands inside running containers. Useful for administration and troubleshooting. Does not require creating a new container. Commonly used in production environments. Docker exec syntax. Docker exec container_id command. Executes a command inside a running container. Returns the output immediately. Useful for automation tasks. Opening a shell with docker exec. Docker exec at container_id bash. Connects to a running container. Opens a bash shell. Provides full interactive access. Using sh instead of bash. Some containers do not include bash. Use docker exec at container_id sh. Common and lightweight images. Practical workflow example. Step 1. Docker run jinx. Step 2. Docker ps. Step 3. Docker exec at container_id bash. Executing single commands. Example. Docker exec container_id ls. Executes the command. Returns output immediately. No shell session required. Common use cases. Troubleshooting applications. Viewing logs. Inspecting configurations. Testing commands. Checking installed software. Viewing running processes. Useful commands. PS. Top. These help identify active processes. Inspecting files and directories. Configuration files. Application files. Log files. Data directories. Shell access makes inspection easy. Security considerations. Restrict unnecessary access. Use least privilege principles. Monitor production environments. Avoid unnecessary root usage. Common beginner mistakes. Forgetting to use it. Trying to access stopped containers. Assuming bash exists everywhere. Exiting containers accidentally. Key commands recap. Docker run at Ubuntu. Docker exec at container_id bash. Docker exec at container_id sh. Exit. Docker ps. Key takeaways and lesson summary. Interactive containers provide direct access. I enables interaction. T creates a terminal session. Docker exec accesses running containers. Shell access is essential for troubleshooting and administration.